Hi students, welcome to Max Point of View. Today we are going to understand the concept of household circuit, that to part A, transmission of power and house wiring. This chapter is very easy. This chapter has 3 block diagrams. If you understand all the 3 block diagrams properly, then you can solve any question from this chapter. Okay, after understanding the concept of part A, we are going to solve each and every theory question, so that you will not only understand the concept, you can get to know what kind of questions they will ask in the board exam. So after watching the concept video, my suggestion is go for the theory questions immediately. If you learn the concept today and if you go learn the concept, if you are trying to learn the concept a day after tomorrow, after few days, you are going to forget the concept. So after learning this, learn the theory solution immediately. You will understand the concept in 100%. So before going to house wiring, we need to know where the electrical energy or electrical power is coming from. See, do you think whatever the energy or whatever the electricity we are using is generated in the city? No, it is generated outside the city, and that is too far away from the city. So now we got to know it is not generated in the city. What voltage is generated? What voltage is generated? So see, in the power generating station, okay, generating station, 11 kilovolts is generated. So this is power generating station. In power generating station, the generated power will be, the generated voltage will be 11 kilovolt. K should be small, okay, V should be capital. K means kilo, kilo means 1000. 11,000 volts is generated. 11 kV means 11,000 volts is generated. So you might get a doubt that why only 11 kV, why not more than 11 kV? See, for more than many industries, we require 33 kV, 33 kilovolts. But how much we are generating? Only 11 kilo. How can we convert this 11 kilo into 33 and any other voltages? That we are going to learn now. See, first we need to understand, anyhow we require 33, maximum is 33 kV we require. Why we have to generate only 11 kV? Why? Because more than 11 kV, if we want to generate more than 11 kV, it will cause us a problem of insulation. There will be a insulation problem, and we can now we are going to convert this 11 kV to 132 kV. 132 kV. Once this 11 kV is generated, it is transmitted to grid substation. Grid substation. Here, whatever the voltage is generated, that will be stepped up. What do you mean by stepped up? Stepped up means, see, we are everywhere, wherever we have block diagrams, we are going to use transformers. So what is the simple function of transformer? Whatever the voltage you give, I can increase the voltage or decrease the voltage. See, I'll repeat it. Whatever the voltage I give to transformer, the only function of a transformer is to step up. Step up means increasing the voltage. Step down means decreasing the voltage. And more about transformers we are going to learn in our next chapter, that is nothing but electromagnetism. Now we need to just know, stepped up means, step up transformer means the increase in, it will increase the voltage. Step down transformer means it will decrease the voltage. Now from 11 kV to 132 kilovolts. 132 kilovolts, it is stepped up. We don't require 132 kilovolts, but why we have to step up to 132 kilovolt? Very simple. Listen, I told you we cannot generate more than 11 kV. Correct, more than 11 kV. Why? Because it will cause insulation problem. It will cause insulation problem. So and why we can, anyhow we got to know we can aram say step up any voltage to any voltage, then why we have to generate only 11 kV? Why not less than 11 kV? You see, for 11 kV it will cost more amount, right? More money. But if we generate around 1000 kV, not 1000 kV, sorry, 1000 volts, this is 11,000 volts, right? Just 1000 volts. Why we cannot generate 1000 volts? And anyhow we have the knack of stepping up whatever the voltage we want, aram se we can step up. But what is the problem? Why we are not generating less than 11 kV also? We got to know why not more than 11 kV. We need to know why not less than 11 kV also. Listen, when it comes to power, voltage and current are inversely proportional. Keep that in mind. Voltage and current are inversely proportional. See, according to Ohm's law, voltage and current are directly proportional. Ohm's law, when it works, only when the temperature remains constant, correct? But when it comes to power transmission, temperature will never be constant. Then voltage and current will be inversely proportional. So here, if I generate less than 11 kV, voltage will be less. If the voltage is less, what happens to the current? Current will be more. If current is more, heat generated will also be more. See, all these things we have learnt in electricity chapter, correct? See, in electricity chapter we got to know power voltage and current are directly proportional only when the temperature is constant. When it comes to electrical power, voltage and current will not be directly proportional, they are inversely proportional because the temperature is not constant. And if I can produce less than 11 kV, aram se we can step up. But when we generate less than 11 kV, what is this? Voltage. If the voltage is less, current will be more. If the current is more, heat generated will be more. Heat generated will be more means the loss of energy will be more. That's why we are only sticking with 11 kV. Now you got the reason, right? Why we have to only go for 11 kV. Why not more than 11 kV? Why not less than 11 kV? More than 11 kV, it causes insulation problem. Less than 11 kV, current will be more. If the current is more, heat generated will be more. That is loss for us. Heat generated means loss of energy in the form of heat. So both the things you should know. In the exam, we have to be prepared for everything, not only for the questions which is there in the textbook. See, they have asked why not more than 11 kV. They never asked why not less than 11 kV. But if we are prepared for that, in the board exam, if they ask the same question, we cannot predict any question which they are going to ask in board exam. If you have seen 2024 paper, question paper, ICSE grade 10 2024 paper, the paper was completely logical. Okay, if you know the basic concept, you can answer any question. But the only thing you need to know is, this question is from which chapter, which concept, and what is the condition for that concept. If you know that, aram se you can crack the answer. Now we need to know the frequency also. Frequency, okay, at the generating station it is 50 Hertz, and frequency at all the station will be 50 Hertz only. Okay, throughout India we are using 50 Hertz. In different countries they are using different frequency, but throughout India we are using 50 Hertz only. So in all the substation till it reaches the consumer, the frequency will be 50 Hertz only. Frequency will never change. Keep that in mind. One of the question is asked based on the frequency also. Frequency will never change. See, not only learning frequency will remain constant, you need to understand what do you mean by 50 Hertz frequency. 50 Hertz frequency means, see what energy we are using, electrical energy. In electrical energy there are two types, AC and DC. DC current will have constant magnitude, and it will only go in one direction. Okay, it will only move in one direction. But when it comes to AC, it can move in both the direction, and the magnitude of current or magnitude of voltage aram se we can change. Listen, that is why we are using only AC current. AC current. See, whatever the voltage we are getting, that will be AC. It is not DC. Why not DC? This question they will ask. Why we cannot use DC current or DC voltage in power generating station? Why? Because it cannot be stepped up or stepped down. We have understood what is stepped up, what stepping up or stepping down. Stepping up means increasing the voltage, stepping down means decreasing the voltage. In DC current or DC voltage or DC power, we cannot step up or step down the voltage. Keep that in mind. Okay, now whatever the generated energy will be of AC only. Okay, it is not DC current, it is AC current. Okay, now we got to know the frequency, generated voltage. Now this generated voltage is given to grid substation where it is stepped up to 132 kilovolts. Why we have to convert into 132 kilovolts? Why? Because we know there will be a loss of energy, correct? Whenever we are transforming the electrical energy, there will be a loss of energy. To compensate that, okay, to compensate that, 132 kilovolt will be stepped up. Now once we convert into 132 kilovolt, it is given to main substation, main substation. Okay, so here it is stepped down at 33 kilovolts. Okay, from 132 kilovolts it is stepped down. Down means it is decreasing the voltage. So what type of transformer we are using here? Step down transformer. Here it is step up transformer. So generated voltage is 11 kV and it is stepped up to 132 just to compensate the loss of energy, and it is step down, again step down to 33 kilovolts. Why particularly 33 kilovolts? Because high industry, okay, heavy industry, okay, heavy industries requires 33 kilovolts. Okay, to give the power to the heavy industries, it is exactly step down to 33 kilovolts. Next, whatever the stepped down voltage 33, it is given to some heavy industries, and again it is taken parallelly, parallel connection, it is given to intermediate station. It is given to intermediate station where again it is step down. For stepping down, what transformer we are using? Step down transformer. See, to decrease the voltage it is step down transformer, to increase the voltage it is step up transformer. See, only in grid substation we are using step up transformer, everywhere we are using step down transformer only. Keep that in mind. Step down at 11 kilovolts. Again it is exactly converted into 11 kilovolts. Why? To give it to, see, this 33 kilovolts is given to heavy industries, 11 kV is given to light industries. Light industries. Okay, now after giving it to light industries, again we have taken the parallel connection. Now from that it is given to city substation. City substation, and here also it is stepped down at 220 volts. City substation, here it is stepped down to 220 volts. That is what we are using in our houses. So in our houses, what is the voltage we are using? 220 volts. So once it is stepped down, it is given to the consumers. That is nothing but us. So this is the block diagram. See, in this chapter there are 3 block diagrams. So if you can understand all the 3, then this chapter you have understood clearly. So see, they may ask you to write the block diagram, or most of the time in particular place, okay, in particular place they will ask you any give reason question. They'll ask why AC, why not DC, why only 11 kilovolts, why not more than 11 kilovolts, why not less than 11 kilovolts, what is the frequency in city substation. See, we know frequency will remain same everywhere, okay, from generating station to the consumer it is 50 hertz only. Then which type of transformer is used in grid substation, which type of transformer is used in intermediate city substation, main substation. Only in grid substation we are using step up transformer to increase the voltage, else everywhere we are using the step down transformer only. Then 33 kilovolts, why, where it is given to heavy, 11 kilovolts it is given to light industries, and in city substation it is given to consumers. That's it. If you know all these questions, okay, all these, if you have this complete knowledge, you can answer any question. You will get to know once we are solving all the theory question from this chapter. After learning this concept video, we are going to solve each and every theory question. That video will also be available in the description box. See, as I told you, the complete power transmission and house wiring system has 3 block diagrams. One we have already learnt, that is nothing but transmission of power from the generating station to the consumers. Now from the whatever the consumers getting, from that to different houses in a same building. See, this is the complete connection of one building from starting point to the different houses of the same building. We know in one building there are different houses, like they have given it for rent or lease or anything, or they are using for their own purpose, all those things. The connection to a building from that point to different houses in the same building we are going to learn. After that, in different houses, see, in different houses what is the connection, that we have one more diagram. Okay, if we learn all the 3 diagrams, this is the second diagram. In a different houses there will be different connection, right? That also we are going to learn. That is the easiest diagram. This is also very easy. If you know the concept, then it is very easy to answer any question. Okay, listen. First thing, whatever the power is given, okay, see, we are going to get the electrical energy or electrical power from 2 different sources, any one source, not both the sources. See, from the pole, from the electrical pole, see, we have seen many times outside our houses there will be a pole. From on that pole there will be a thick wire, right? So in that case also we can get the electrical power, or from underground, from the Bescom. See, we are in Bangalore, right? So from the Bescom, okay, we can get the electrical power in overhead lines. Overhead lines means from the poles, okay, electrical poles, or we can get the power, electrical power supply from the Bescom through underground cables. So any one possibility is there, we can get any one. Okay, now listen. So from the Bescom or service provider or the source, we can call it as source, okay, we will get 3 wires. Keep that in mind. How many wires we are going to get? We are going to get 3 wires. So this is very much important. Throughout this chapter we are going to talk about 3 wires. So we need to know the names of it, we need to know the functions of it, then it is easy to understand everything. So there are 3 wires. I told you this is live wire, live, this will be this one, second one will be, see, this one, from the source only we are getting all the 3 wires, neutral, and this one will be earth wire. Okay, live wire, neutral wire, and earth wire. Live wire has 2 more names. Okay, live wire has 2 more names, live wire or line, L-I-N-E, line wire or phase wire. Okay, we can call it in any other names. So this question was also asked one time in board exam. What is another name for live wire? You can write line wire or phase wire, any word is fine. Now listen, so we got to know from the source we are getting 3 different wires, that is live wire, neutral wire, and earth wire. Now what we need to understand the functions of it. Live wire carries the actual voltage from the source. From the source, whatever the voltage we are getting, that will be transmitted from live wire. Okay, after the usage, whatever the voltage is left, that will be given back to the source using the neutral wire. These are the 2 functions of live and neutral wire. Then what is the function of earth wire? Listen, whenever there is a high voltage due to the faulty connection, sometimes there may be a high voltage, or due to the lightning, okay, we may get very high voltage, that that voltage cannot be withstand by our houses. So what we are going to do is, we are going to do the earthing connection. This is the symbol for earthing connection. So what happens when you do the earthing? See, local earthing is there. All those things we are going to learn in part B. Part B. For now, you need to know what do you mean by earthing. Earthing is nothing but, so the connection will be given to the earth whenever the high voltage enters the house. Whenever the high voltage enters the house from different sources, okay, that will be given back to the earth, so it will not affect the house or a building. Now these are the 3 wires and these are the 3 different functions. Now next, first, whenever we get these 3 wires, the first connection is given to the company fuse. Company fuse. Listen, what do you mean by company fuse? See, this is the picture of company fuse. So I think many of the students have seen this picture. Okay, listen, what is the function of company fuse? See, company fuse, why they are calling it as company fuse? Because this has been installed. Okay, this will be installed from the company. What company we are talking about? The service provider. In Bangalore it is Bescom. So this company fuse will be installed from the company, and this company fuse has one more name, that is pole fuse. See, in the exam they may use any word, you should never get confused. Okay, what do you mean by fuse? This we have already learned from the electricity chapter, that's okay. Anyhow, we are starting the chapter, I will teach you. Listen, this is the fuse and this is the appliances. Okay, anything you may talk, we can talk about any fan or any appliances, anything. Listen, whenever this is the live wire, okay, fuse and switches is always connected to the live wire, keep that in mind. Fuse, okay, mainly fuse is always connected to the live wire, keep this in mind. Most of the time they are going to ask this question, why it should not be connected to a neutral wire. All those things we are going to learn in the theory solution. Now you need to understand only one thing, why fuse is always connected to the live wire. When the fuse is connected to the live wire, we know what kind of current we are using. AC current. What do you mean by AC? Alternating current. So the magnitude of current will not be constant, it will keep on changing. We assume this appliances, we are talking about fan, we can talk about any appliances. Now this fan or this appliances have this one rating of 5 amperes. 5 amperes means more than 5 amperes comes from the source, that will definitely damage this appliances. So what I'll do is, I will install 5 ampere, okay, of fuse. 5 amperes of fuse, or little more than that, 6 is also fine. Okay, 5 amperes of rating means it more than 5.01, okay, will not affect these appliances. More than 7, more than 8, like that. If more than 8 or more than 7 amperes comes, then that current will definitely damage these appliances. So what I'll do is, I'll install 5 amperes or 6 amperes, anything is fine. Little more than that or exactly that value, whatever the value is given, that is also fine. So I'll install a fuse. Whenever a current of 8 amperes comes, this fuse will melt. This, whatever the material we are using here, lead and tin, what kind of materials we are using? Lead and tin alloy. Okay, so that will melt, so there will be no connection between the source and the appliances. So for a faulty current, this appliance will be safety. So fuse is a safety device. All those definition they are going to ask. Okay, don't worry about it. In depth, we are all these definitions, all those things we are learning in part B. Now we need to understand, we should know just the function is enough. So now we got to know the fuse. So this company fuse or pole fuse will be installed by the company with the current rating of 50 amperes. Okay, 50 amperes. See, this 50 amperes is not constant, it is different for different buildings. So for generally we are going to take 50 amperes. This is the rating given in the textbook. So company fuse current rating will be 50 amperes, keep that in mind. So there are 2 different fuses we are going to use. Okay, one is company fuse, one is main fuse. Okay, that is nothing but MCB. I'll talk about that later, don't worry. Now company fuse or pole fuse, okay, as a current rating of 50 amperes. Why this is installed by the company, why not from ourselves? Why? Because if you don't pay the electricity bill, they are going to take this fuse. Okay, they are going to take this fuse, then there will be a problem. That's why it is installed by the company. Okay, that is why it is called as company fuse or pole fuse. It has a current rating of 50 amperes. See, fuse is always connected to the live wire. Keep that in mind. See, we are going to get the 3 wires, live, neutral and earth. Only the live wire is given to the fuse. From the fuse it is again continued, and neutral wire and earth wire is given to the kWh meter. kWh meter, it has one more name. kWh, what do you mean by kWh? It is the unit of electrical energy, kilowatt hour. That is the unit of electrical energy. So kWh meter has one more name, that is nothing but meter board. Okay, meter board or kWh meter. So in this board, okay, this is the only place where all the 3 wires are connected, and I forgot to tell one more thing. Whenever the 3 wires are coming, okay, the neutral and earth wire will be joined together, and they will ask one question: which of these 3 wires, okay, out of these 3 wires, which 2 wires has same potential? See, we are getting the source, we are getting the voltage from the live wire, and neutral wire and earth wire will be joined together, and neutral wire and earth wire will carry the same amount of voltage, that is nothing but 0 volts. Okay, these 2 are not carrying any voltage, right? So these 2 are carrying same amount of voltage, that is nothing but 0 volt. In the exam they may ask you which 2 wires will carry the same potential difference or same voltage, that is nothing but neutral and earth wire, and how much voltage they are carrying? 0 voltage. That's it. Next, so only to the kVh meter, okay, kWh meter or meter board we are connecting all the 3 wires. Next, here what is the function of this one? It will note down all the values, how much power we are consuming. So based on this meter only we are going to get the electricity bill. Next, from the kWh meter, okay, only 2 wires are given, live and neutral wire to main switch. Okay, this is the picture of main switch. So this is how it looks. So nowadays this picture is also replaced with this one newly innovated design. So now you should not get confused. Only thing you need to know is, don't worry about the picture. You need to understand what is main switch. Okay, what is the function of main switch. Now main switch is also called as ELCB. See, all the different devices have different names also. MCB also has one more name. So you need to know all the names and function. If you know the function and all the names, that is enough. So then diagram. See, they may ask you this diagram in the board exam. Till now they did not ask like that, okay, the block diagrams, but in the exam definitely give reason questions or functional questions. What is the function of company fuse, what is the function of kWh meter, main switch, MCB, all those things they can ask, and different current rating, and they may ask you in different words, using different words. So main switch has one more name, that is ELCB, earth leakage circuit breaker. Now what is the function of this main switch? Okay, this main switch acts as dual pole switch. What do you mean by dual pole switch? Very simple, but whatever the explanation I am giving, that is not there in the textbook. Don't worry. Assume there is a switch, okay, you can connect it here or you can connect it like, okay. Now listen, the switch, this has, okay, dual pole switch, that means it has 2 switch. You can connect it like this or you can connect it like this. So you can connect it to live wire or you can connect it to neutral wire, anything. Next, listen, dual pole switch, this is the meaning of dual pole switch. Don't worry about it. First thing you need to know is main switch will act as dual pole switch. Now what is the main advantage of dual pole switch or main switch? We can break. See, assume it is connected to live wire or you can connect it to neutral wire. Okay, the main switch can be connected to either neutral or live wire. So when it is not connected to anything, assume it is at the center. it is at the center. What do you mean by that? You can break the live connection. Okay, you can break the live connection and neutral connection simultaneously. At the same time, we can break both live connection and neutral connection just to ensure the safety of the building and also the humans. Okay, now you got the function of dual pole switch. What do you mean by dual pole switch? You can break the live connection and neutral connection simultaneously. So that is the main function of main switch, and main switch has one more name, ELCB, earth leakage circuit breaker, and it acts as dual pole switch. What do you mean by dual pole switch? That they are not going to ask, but you need to understand. You can connect it to either live or neutral. But what is the main function of dual pole switch? You can break the live connection and neutral connection simultaneously. Next, see, this main switch has only two connection, live and neutral wire. Now from this connection, okay, from the main switch, two wires will go, that is nothing but live and neutral, and from that, see, from here earthing connection will be taken. Earthing and neutral connection will also be there. See, don't worry about it. Don't worry about the diagram. You need to understand which devices have which kind of connections. Listen. So every MCBs will have one live. Okay, the top one is live, neutral, and earthing. Okay. So here this is called as tapping. Tapping means it is not connected from this point to these two lines. It is jumped. Okay, separately connected. That is nothing but tapping. Okay, now see, everything will have from here. Okay, listen. So MCB has one more name, that is called as main fuse. Okay, why MCBs are required? Main fuse is required. Listen, we know we are getting the electrical energy from the source till the meter board, from the meter board to main switch, from the main switch to MCBs. All the MCBs represents different houses in the same building. So for a different house, different house in the same building will have MCBs. What is that? That is nothing but main switch, main fuse. So whenever the faulty current enters, if that escapes here, assume the faulty current is there here also. Okay, here see, we for the whole building we require 50 amperes of current. So that 50 amperes of current is distributed, and the current rating of MCBs, all the MCBs which we are using, main fuse or MCB, is 30 ampere. Keep that in mind. Okay, current rating of different MCBs are 30 amperes only. Main fuse, company fuse is 50 ampere, main fuse is 30 ampere. What do you mean by 30 ampere? More than 30 amperes of current comes, this MCB will trip. Initially we used to have fuses that will melt and we have to replace it. Nowadays we are using MCBs. MCB is nothing but miniature circuit breaker. When the high current comes, this MCB will turn off automatically. This is nothing but called as tripping. So it tripped. So again we have to turn it on. That's it. So this is how MCB works. Now from the main switch, MCB one connection is given. See, for MCBs you need to know how many wires are connected. Only live wire. For fuse, okay, for a fuse and MCB, only live wire is connected. Neutral wire and earth wire will move along with that to give it to the different appliances like a fan and washing machine, all those things. See, till here we need to understand. Okay, from the source to the different houses of the same building. This is the house wiring system. Okay, in that house wiring system, from building to a different houses, if we learn, okay, inside one house, how the connection is done, okay, that will be the third block diagram. If we learn all the three, then we have completed the complete part of part A. So here very important things are different names and functions and power rating and what kind of wires are connected to different devices. See, for the company fuse only the live wire, only to the kWh meter or meter board all the 3 wires are connected. For a main switch only live and neutral wire, and for MCBs only the live wire. What is another name for MCB? Main fuse. What is the current rating of that? 30 amperes. What is the expanded form of MCB? Miniature circuit breaker. All these things if you know. Okay, what do you mean by dual pole switch? Okay, all this diagram is not required. Just to make you understand, I wrote this one. So all these functions, if you can understand, you can answer any question. Now we'll talk about the third and final diagram. This is the conclusion diagram. Very simple. Listen. So in the first diagram we have learnt from generating station to the consumer. In the second diagram, from the consumer, okay, that is nothing but the us, okay, us, from starting point to till the different houses in the same building. Now we are going to talk about one single house in a building. We know in a building there will be different houses. In one house we are going to talk. This will remain same for everything, and this is called as ring system. Ring system means it should be in circular form, correct? But the closed path is considered as a ring system. Listen, till MCB we have learnt, correct, the second diagram. Now from the extended form of this connection, listen, from the MCB we know what is the current rating, that is 30 amperes. If more than 30 amperes current comes, this MCB will trip off. Trip off means turn off automatically. We need to turn it on so that it will work normally. All the appliances will work normally. Now, okay, now listen, we know for only the live wire should be connected to the MCB which has 30 amperes of rating, and we have other 2 wires also, neutral and earthing. See, the live wire is given here, okay, neutral wires has taken a tapping, okay, listen here, a jumping, so that there will be no connection between live and neutral wire. Then earth connection is jumped twice, is connected inside. Okay, this is very useful. This kind of diagram is useful. Why? You will understand here. Assume in a different house or in a different room we can use many appliances, correct? I can use lamp and I will use the socket. Okay, in a different house there will be many sockets, correct? There will be many sockets, and see, we are going to learn only one socket. In that socket only whatever we are going to plug it in, like a washing machine or a motor or anything, okay, we can use it. In board exam they may ask you lamp or fan or any other washing machine also. The diagram remains same, only what are the things it should be connected, that you should know. See, for a lamp, okay, or a bulb, what do you think that requires high power, high current? No, it requires normal current only. Whenever an appliance uses normal current, then it does not require earthing connection. It does not require earthing connection. That's why for a lamp I have given a fuse, separate fuse. We can give it or you can remove it, anything is fine. See, for a normal lamp we will give you fuse and one switch, fuse and switch, okay, which is connected to the appliances should always connected to the live wire. See, this is the live wire, right? This wire is going here. So the for a bulb, fuse and switch should be connected to the live wire, and from the another end of the bulb it should be connected to the neutral wire. It does not require earthing connection. Why? Because it does not require huge power. Which appliances requires huge power? That requires earthing connection, because whenever the huge power is there, high voltage will enter, high current will enter, and if there is any faulty thing is there, then that will definitely damage the appliances. So whenever the faulty current or faulty voltage enters, that will be given back to the earthing connection, so that there will be no problem for the appliances. Now here there is a socket, correct? Socket has 3 pins, correct? Socket has 3 pins. The upper one will be, okay, has bigger hole compared to the other 2. That is connected to the top one is connected to the earthing connection. Okay, one is connected to the live, other is connected to the neutral. Which is live, which is neutral, and why that has a bigger hole, all those things we are going to learn in part B. Okay, part A we are going to learn the connection. In part B we are going to talk about different devices, okay, like fuse and socket, plug, all those things we are going to learn in part B. Now only thing you need to know, one live wire should be connected to the live connection. Okay, in the live wire only switch and fuse should be connected. If in some in exam, if they are asking connect one bulb and a fan. Okay, for a fan, instead of fuse you can go for the pot, the resistor pot, or else you can go for rheostat. Okay, here instead of that you can connect it like this. Okay, here instead of the fuse you can connect the pot. The pot will be like this. Okay, just to change the current, so that we can change the speed also. So in the exam, if they are asking for a fan, instead of fuse you can use the pot. Okay, now listen. So from I told you from the live connection only, wire only, the fuse and switch should be connected and given to the live, and from the neutral it should be connected to the neutral, from the earth it should be connected to the earth. That's it. Okay, if they are talking about a bulb, this is the connection. It does not require earthing connection. Okay, fuse and switch is compulsory for everything. And just it, instead of socket, if they are asking washing machine, you connect, just you write washing machine here, that's it, the connection remains same. So this is the house wiring system. So in one single house we can say there will be more than 3 to 4 bulbs, and there will be more than 3 to 5 sockets and many appliances, right? So this is how it will be done. So whatever we do, everything will be connected parallelly, so everything will receive same amount of voltage. Just now we have learned how to draw the ring system. Now we will understand advantages of ring system. See, the first one is cost. The ring system is cost effective. Okay, it is cost effective. Next, each appliances, we have learned in each appliances can have their own fuse. Each appliances can have own fuse. Then the socket and the plug can be of same size. Plug and socket can be of same size. For every appliances, the plug and socket, the size can be same. Aram se we can use it without any problem. Then it does not require new connection, okay, new wire connection for any new appliances. That means if you want to install, okay, assume in the first year you will bring TV, next year you will bring washing machine, you will keep on adding the electrical appliances, correct? For these appliances, for new appliances, we don't require new connection. Anyhow, the ring system is there, okay, we can just tap the connection, we can take the connection aram se. Next, each appliances will receive required voltage, okay, required voltage, since they are connected parallelly. Okay, all the appliances are connected parallelly. What is the main advantage of parallel system? Each appliances will receive same amount of voltage, so the voltage will not divide in parallel connection. So these are the advantages of ring system. See, in all the diagrams we have learned, all the appliances are connected parallelly, all the different appliances are connected parallelly, but the fuse and the switch for the particular, all the appliances are connected series. Listen, assume this is the bulb, okay, there is one switch and a fuse is there. This is the live wire and neutral wire, correct? So for appliances, the fuse and the switch is connected in series for an appliances, but different appliances, assume you can take one more bulb, okay, or any fan, anything, all the different appliances are connected parallelly, but the switch and the fuse and the switch are connected in series with the appliances. Now we need to understand what are the advantages of parallel connection. Very simple. Each appliances will receive 220 volts from the main. Why? Because it is connected parallelly. In parallel connection, voltage will not divide. Next, the second one, very simple. If one appliances get damaged, then all other remaining appliances will work normally because they are connected in parallel separately, correct? So parallel means separate connection is given. So if one appliance is damaged, then remaining appliances will work normally without affecting them. Okay, then we'll go for disadvantages of series connection. What are the advantages of parallel connection? Those will be two disadvantages in series connection. And one more thing, whenever we add a new connection or a new appliances, the resistance will increase, and the new appliances and all the appliances will receive less power. Okay, when we introduce new appliances, if it is connected in series, now everything is connected in parallel. If it is connected in series, if I introduce one more new appliances, then it receives not only that, all the appliances which are connected in series will receive less power, so that it will not work properly. So these are the advantages of parallel connection. These are the disadvantages of series connection. Okay, now we have completed the part A. Okay, part A of household circuit. Here we have learnt 3 different block diagrams. If you can understand all the 3 block diagrams, and these are the advantages of connecting it parallel and in series. So if you can understand all these things, any question in the exam you will be able to answer. So after learning the concept, it is not only you have learnt only 30 to 40%. You know the concept, but you don't know what kind of questions they ask. That is how the theory questions works. So now we are going to solve each and every theory question which is there in your textbook. Okay, and we are going to not only solving it, we are going to understand the method how to solve it. So that video will also be available in the description box. Anyhow, the household circuit doesn't have numericals from each part of the chapter. Okay, part A concept video and theory solution, in part B concept video and theory solution. All those links will be available in the description box. In the description box, all the videos of different chapters, complete chapters, playlist will also be available. So you can jump from one chapter to another chapter aram se. And after solving all the videos, after solving the questions from all the chapters, and after learning the complete chapters, we are going to solve each and every question which was asked in board exam since 2017 to till year. Okay, so we are going from chapter wise, so that you will get complete knowledge about one chapter, what kind of questions they are asking in board exam. I'll give you one example. From household circuits, what are the types of questions they will ask in the board exams? Okay, until now what are the types of questions they have asked? All those things with solution we are going to learn. For that we need to complete all the chapters. Once we done with it, we are going to do those videos. Thank you.